Okay, so we're going to go over 4.1, which is solving linear equations. And when you're solving linear equations, you're really just thinking what is going to make, what number will make this equation true. So in this variable down here, we're looking for what number will make it true. And that's actually what a solution is. A solution is just a number that makes an equation true. All right, so it says fill in the blanks and complete the table. Okay, so use what kind of operations? So the word is inverse, and inverse means to undo. Inverse means to undo. So if I said subtract 4, what would be the inverse operation? That would be add 4. And then if I divide by 10, what would the inverse of that be? Well, what would undo that? Well, multiplication. So multiply by 10. And notice the number doesn't change. Add 4, subtract 4, add 4, multiply by 10, divide by 10. Those are the same number. You're just changing the operation. So how do you undo closing a door? You'd open the door. And so when you're opening the door, it's still a door, but you're changing the actions towards that door. Okay, so a solution to an equation is a value for the variable that, I said this before, makes the equation true. So makes the equation true. Okay. All right. So they're asking, is x is equal to 10 a solution? So all you're going to do is you're going to substitute back in, this is not anything new. So you're going to substitute 10 in for x. So instead of writing that x there, I'm going to put a 10. And then I'm going to see if that equation is true. So 10, take away 5. The 10 is going to appear here. 10 take away 5 is 5. I'll just continue and ignore it. And then does 5 equal to 3? So no, 5 does not equal to 3. So it's not a solution. It's not a solution. And the reason why it's not a solution is because 5 isn't the same as 3. 5 isn't the same as 3, right? Okay. So, all right. So then I want you to plug into the next one. And the next one says, is 8 a solution? So you're going to do the same thing. And you're going to plug in 8 for x. And then you're going to figure out what 8 minus 5 is. 8 minus 5 is 3. And then you're asking yourself, this is a question, does 3 equal 3? And you're like, yeah, 3 equals 3. So therefore, 8 is a solution. So again, you're just going to fill in these blanks for the next part. So to find a solution, you need to what the variable using inverse operations. Well, that second word is going to be operations. And what do you want to do with the variable? Well, you want to isolate it. You want to get it by itself. And that's what isolate means, put it by itself. So operations in an equation. Okay, so the very first thing that I see is I subtract 5. So how do you undo subtracting 5? Well, you'd add 5, right? And so I'm going to add 5 to both sides. So here's me adding 5 to both sides. What happens to minus 5 plus 5? What if you take a number and you subtract 5 and you add 5 to it? Well, then that's just the original number because negative 5 plus 5 is 0, right? They undo each other. That's what inverse means, inverse. So 10 plus 5 is 15. And then, of course, you want to check your solutions. This is the best. I will tell you right now, this is the reason why I like math the most, is because I have a way to make sure and verify that I'm right. So I'm going to check my solution. I'm going to put 15 in for here, and I'm going to see if that's a true statement. Is 15 take away 5 really 10? And you're like, yes. And then so Ms. Johnson, she puts a happy face because that means that you can't take away any of my points. So now I want you to try this one on your own and see if you can come up with the correct answer. Go ahead and pause that video. Okay, so now I want you to try x plus 7 equals to 11, and you should have done this work. If you got stuck anywhere, no big deal. Now just figure out what you didn't remember and remember that for the next time. So So what do you see happening to X here? What do you see happening to X? Oh, well, we're adding 7. So, okay, well, if that's true, what's the inverse of that? How do you undo adding 7? Well, we'd subtract 7. Okay. Okay, so now I'm going to actually perform these operations in this little area. So I'm going to copy the equation x plus 7 equals to 11. And then you said that I needed to subtract 7 in order to undo adding 7. So I'm going to write it a different way. I'm going to write it right below it. I'm going to subtract 7 from both sides, just like this. And whatever you do to one side, you have to do the other because this is an equation and you want to keep the solution true. You want to keep this equivalent, right? So whatever do we do to one side, we have to do the other. So then what are we left with? Well, minus 7 plus 7, those two undo each other. So I'm left with X. And 11 minus 7 is just 4. So according to this, my answer is 4. So my answer is 4. And then I'm going to check my solution. 4 plus 7, you said is 11. Is that true? Is 4 plus 7 really 11? And you're like, yes, Miss Johnson. And she's happy because you can't take any points away from me because I just checked my answer. Okay. Now, no matter what, these steps are pretty much going to be the same over and over and over again. And this is a review for those of you who are thinking, man, Ms. Johnson, I feel like we've done this before. You have. But now we're just adding another level to it when we add 2 steps equations and in just a little bit. This is just review. All right, so here they're like, hey, what are you doing to X? And they're like, oh, I'm dividing by 2. Well, what's the inverse operation? Well, it's multiplying by 2. And then, so then you multiply by 2 for both sides. So now I'm actually going to multiply 2 by both sides. And so I get these 2 divided by 2 is just 1. So these divided by 2 is just 1. And 1 times X is just X. 2 times 5, well, that's 10. And so I think my solution is 10. So then we check our answer. We're going to plug 10 back into our original equation for X. So then if we take 10 and we divide it by 2, we get 5. Is that true? Yeah, that's true. Again, happy face. Okay, so go ahead and try this one out here on your own. Pause the video and come back and check with me. Okay, so now that you're back, we're gonna check. So what is happening to X? Well, X is being multiplied by 4. So I'm gonna write multiply by 4. And how do you undo multiplication? Well, we divide by 4. Right? And you're like, okay. And so now you're actually going to do it. So you're going to take 4x equals to 24. And I'm going to perform those operations. You told me to divide 4 by both sides. So I'm dividing by 4 here, dividing by 4 here. And if you notice here, 4 divided by 4 is just 1. So I'm just going to make this a 1. You guys all see how that's a 1 now? Okay. So then 1 times x is just x. So I'm going to leave it as x. And what's 24 divided by 4? 6. Very good. So x equals to 6 is my answer. I think if I did everything correctly, I think my answer should be right. So to verify that your answer is right, you're going to plug back in over here. So we take our equation and we say 4 times something equals to 24. And then we take our x and we plug it in here and we get, okay. So then we get 4 times 6. Oh, that's 24. 24 equals to 24. Check, happy face, right? And we always want to check our answers because it's like, this is like one of those things, the easiest way to get an A on a quiz is by just checking some of your answers. Whenever you're solving an equation, you can definitely always check your answers, therefore verifying and knowing that you're right. Moving outside of this class, right? You always want to verify the work that you did. You know, did I clean up the bathroom correctly? Did I miss anything? Did I vacuum correctly? When the cashier was charging me money, did she do it correctly? Did all the money, was the money counted correctly? You always want to verify your steps. That's part of, kind of growing as an adult. So this has very much to do with the outside world. Okay. So now you're just they're just doing stuff step by step. I will take this to the side. And here's the thing. So what I want you to think about is I need you to make a list of what is happening to X and in what order. So before we even do this problem here, this is what this very first box is asking you to do, is identify the operations and the order. Okay, identify the operations. And then I'm going to put in order, because we're going to use that order to undo everything. Okay, so the way I want you to think about solving equations is like the best example that I've always given was like, pretend that I'm giving you a present. Okay, so the very first thing I do is I put the present in a box and I close the box, I tape the box, and then I wrap the box up in some wrapping paper, and then I give you the box. Well, in order for you to receive it and find out what's in the box, you did everything that I did in reverse order and you undid it. So the first thing you're going to do is receive the box. Then you're going to unwrap the box. Then you're going to open the box. And then you're going to take the present out. Okay, so same thing goes here. So the very first thing that I do, and I just make a little tiny list right off to the side. I say, okay, well, what's happening to X? If I knew what X was, what would happen first to it? So I'm saying like this, pretend you know what X is. I don't know, pretend it's the number 5. What would happen first to this 5, right? You'd be like, oh, well, if the very first thing is you're multiplying by 2. And I say, okay. And then after I have that answer, what do I do then? You're like, oh, well, then you'd add by 3. Well, when you're solving equations, you use the reverse order. In fact, I call it in my class SAD map. SAD map. Meaning the very first thing you should take care of is the subtraction and addition. SADMAP is PEMDAS backwards. It's in the reverse order, right? First, you receive the box, then you unwrap the box, then you open the box, and then you blah, blah, blah. So everything that we're going to do to solve is we're going to go in reverse order and we're going to undo it. Okay. Excuse me. Oh, okay. So it's just asking you the same thing here. So the variable X is being multiplied by 2 first. Oops, I want to use that other color because I want to multiply by 2. And then 3 is added. So because the 3 was the second thing, that's the first thing that I'm going to take care of. It's almost like that idea of the last will be first and the first will be last. This is what we're talking about here. In programming, it's called there's FIFO, which means first in, first out, and there's FILO, first in, last out, right? And so because this guy was the last one in, he's going to be the first one out. Okay. So we're going to do this, and we're going to undo the addition by subtracting. Oops, I should use the other color because I'm using that to undo things. Subtracting 3. So we're going to subtract 3 from both sides. So just subtract 3 from both sides. And then here we get 2x plus 3 minus 3 is 2x. 9 minus 3 is 6. Okay. Undo one operation. Start by undoing the last operation first. Remember, I talked about last out. First, last in, first out. Last in, LIFO. That's what it means. So we're going to do the last one first. That S looks kind of funny, but that's okay. So, oops. All right. So the next thing we're going to do is we're going to undo the next operation. And so for us, we're just going up this way, or if you're using SADMAP, you're just doing this. We took care of subtraction and addition. Now we're going to do division and or multiplication. Okay, so let's do that. So it says undo. So we're going to undo multiply by 2. Well, how do you undo multiplication? And you're like, oh, division. Exactly. So we're going to divide both sides by 2. Notice that 2x divided by 2x is just the number 1. I'm trying to make a big cartoon one. You guys all see that? So that's just the number 1. I'm trying to remind you that 2 divided by 2 is 1. And 6 divided by 2 is 3. Therefore, you think the answer is x is equal to 3. You need to verify your answer. You need to check your answer. I can't tell you how many students, actually, this should be a different color than that color. I can't tell you how many students messed up very simply because they, were excited because they're like, yes, I know what I'm doing. 6 divided by 2 is 4. And then they put that as their answer and they forgot to check. And if they just would have taken this step, they would have figured out that the answer is correct. So all I'm going to do is I'm just going to substitute again, just the same way that we did before. So instead of writing x, I'm going to put a 3. So then 2 times 3 is 6. My computer is going to catch up to me. So 6 plus 3 is 9. So therefore 9 equals 9. And you're like, yes, that's correct. I'm so happy, Miss Johnson. Yeah, because what you're really trying to do is make sure that you don't lose any points on something that you already understood, but you just made a kind of careless error. Okay, so this next part here, if you have negatives, it works exactly the same. Okay, your rules don't change because it's, oh, we're working with negatives. And so one of the phrases that I like to use in my higher level math classes is because it worked in number land, then it has to work here in polynomial land or, algebra land or geometry land or whatever. Like just because you grow up, right, nothing changes. You just learn more about that something, right, by applying it to different things. So same thing goes here because it works in like with the positive numbers, it's gonna work with our negatives as well. Okay, so same thing goes here. So here what we're going to do is I see that 3, it's being added, and some of you are like, no, it's not, it's being subtracted, but that 3 is positive, right? It's that 2 that's negative. So you got to pay attention. So how do I get rid of a 3? Well, I'd subtract 3. So I'm going to subtract 3 from both sides. And 7 minus 3 is 4. And 3 minus 3 really is 0. 3 take away 3 really is 0. Okay. Computer's going a little slow, but that's okay. So now we have negative 2x equals to 4. And you'd say, okay, well, what's happening to x now? And you're like, oh, it's being multiplied. Good. So how do you get rid of the multiply by negative 2? Well, you would divide. Now, here's where students don't, they kind of mess up a little. They think that they need to change the sign, but we never changed the sign before. Like, when we subtracted 3, we didn't change the sign of that 3. We changed the operation. We went from adding to subtracting. We went from multiplying to dividing, but we never changed the sign of that number, right? So here we're going to keep that 2 as being negative, mostly because I want to make this a 1. And the only thing I could divide negative 2 by and get 1 is negative 2. So negative 2 divided by negative 2 is 1. And 4 divided by negative 2 is negative 2. So I think my answer is negative 2. Of course, you're going to check your answer. So I'm going to plop negative 2 into there. And negative 2 times negative 2 is 4. 3 plus 4 is 7. Okay, so go ahead and take a pause and try this problem on your own to see if you can do this one on your own. All right, so now that you're back, and really try these problems on your own. If you're not trying these problems on your own, I'm going to tell you right now, as a high school teacher, I'm looking at students who don't know how to solve an equation. And how do you think they're doing in our class, where not only are they solving equations like this, they're solving equations with polynomials, or they're solving equations with x squared. If you can't solve an equation like this, for sure, it's going to be really difficult for you later on. So make sure you're practicing this on your own. All right. So then I'm going to, here I say, okay, well, what's happening to my x? Okay, let's do that little practice there. So let's look here. What's happening to x? So pretend you had a number. So like the number, I don't know, 5 again. And I am looking at this and I said, okay, well, what would happen to 5 first? And you'd say, okay, well, first I'd multiply by negative 5, by negative 1, right? And then I would add 4. So if we're solving, we're going to go in the reverse inverse order. Okay, so first we're going to take care of that adding 4. How do you get rid of adding 4? Very good. You would subtract 4 from both sides, of course. So 5 minus 4 is 1. And then next thing we would do is we take care of that multiply. How do you get rid of multiplying by -1? And you're like, oh, well, I divide by -1. And if you don't see this as a -1, just draw him in, right? You can't just divide by a negative. You actually have to divide by a -1, right? So in case you don't know, that the coefficient in front of that x is a negative, but there's a 1 that's invisible that I like to have my students draw in. So if you don't know that, draw it in and you'll get used to it. And the reason why is because -1 divided by -1 is 1. And 1 divided by -1, well, that's a -1. And of course, I want you to check your answer. So let's check your answer. We go like this, negative parentheses plus 4 equals to 5. And I plop that -1 into there, right? Okay, so negative times a negative is a positive. So that's 1 plus 4 equals to 5. And 5 does equal to 5. So again, Miss Johnson, happy. All right. Okay. To solve more complex equations, you may have to simplify or combine like terms first. So complete the table to show how to solve more complex equations. Okay, so when we get over here, when we have variables on both sides, like the thing that you want to do is you want to get to this place over here, eventually where you have variable equals to a number. And so because this has variables on both sides, it is completely legitimate to subtract variables so that you can have variables just on one side. Okay, so for here, I'm going to basically subtract 2x on both sides. So 2x minus 2x is 0. And you're like, okay, so that's just left with 8. And 4x minus 2x, well, that's just 2x. And then I say, okay, well, what's happening to x now? And you're like, oh, it's being multiplied by 2. And I'd say, okay, well, how do you get rid of multiply by 2? And you say, oh, by dividing both sides by 2. And so my answer is 4. And of course, you would check your answer, right? You would check that answer to make sure, now that you understand the importance of checking your answer, make sure you do it every single time. Some students say, hey, Ms. Johnson, because my x is 4, does it go in here or here? And I say, yes, it goes in both. X equals to 4 is true for the whole equation. If you have 10 x's, every single time you'd be like 4, 4, 4, 4. All those are 4. Okay. So now what I want you to do is I want you to try this one. Okay. And try this one and see if you can come up with the idea by yourself, the solution. And then of course, I'd want you to check your answer as well. Okay. Go ahead and pause the video and make sure that that happens. All right, now that you're back, let's try some of these together. Okay, and when we're trying these together, all we're really doing is making sure that we understand that you're making every single step correctly. Again, one of the biggest mistakes some of my students make is, Ms. Johnson, I understand what you do it, but when I get to the test, it doesn't make sense because you're not practicing on your own. Like, for example, I get it, you know, when I watch basketball and I'm like, man, that was a sweet dunk. If I watch people do it and then I try to do it on my own, the very first time is going to look funny, right? So again, I want to encourage you, do it. Okay. So the like terms in this case are 4x and 2x. And they're like terms because they're the same. They look the same. Both of them have x's. And the constant in this case is 2 and 8. Constant means number without x. But if you think about what a constant is, it doesn't change. So if you think about 2x changes, right? Depending on what you put in for x, that value will change. Here, I don't care what x is. 2 is 2 and 8 is 8. Okay, so here I want to put like terms together. So I'm going to subtract 2x from both sides. Subtract 2x. And again, the reason why I do that is because I don't like x's on both sides. So I'm going to subtract x's to put them on together. Okay. So then I get 2x plus 2 equals to 8. And I'm like, okay. And then I don't like this 2. And then again, this is that part where you would use SADMAP right here. Now you wouldn't use SADMAP on this first one because you have x's on both sides. You want to get all the x's on one side and then you can start using SADMAP. So if I ask you about SADMAP and I say, hey, what do you need to do? What happens to x first? Or do you have any subtraction or addition? If you're just going to follow this order here, do you have any subtraction or addition? You're like, yeah, I do. So let's take care of that subtraction and addition. How do you undo plus 2? Someone's like, minus 2, Miss Johnson. Exactly. And my computer is going to catch up. Just be patient. Right. And then I get 8 minus 2, which is 6. And I say, okay, well, how do you undo multiplication? And hopefully you're getting this and you're like, oh, I divide. And then Miss Johnson, my answer is 3. And I'm like, yes, exactly. Then you would go back and check. And I can mentally check this with you right now. Ready? 4 times 3 is 12 plus 2 is 14. So I have to hold 14 in my head. So 2 times 3 is 6 plus 8. Is that 14? And I'm like, yeah. Okay. This is another problem. And I'm always going to tell you to simplify both sides of the equation before you start SADMAPing. Okay. So here I am going to distribute first. So I'm going to distribute first. So here goes 2x and here goes 1. Ms. Johnson, isn't that a negative 1? But they put a minus here. So I'm going to keep this as a positive, right? So here I get 6x minus 3. Excuse me. And then here you can start SADMAPing right here, right? Or you can ask, hey, what happened to x first? So if you're SADMAPing, you'd say, okay, do you have any subtraction or addition? You're like, yeah, I have subtraction. So then I'd say, okay, well, how do you undo subtraction? You're like, oh, add 3 to both sides. Very good. So I get 18 and then we move on. And I'd say, okay, do you have any division or multiplication? You're like, yeah, I have multiplication. So how do you undo multiplication? Just division. So our answer is x is equal to 3. Very good. Okay, so now we're just going to fill in these blanks and make sure that we all understand everything. Okay, so an equation can have how many solutions? Well, we've learned that it can have one solution. Later on, you will learn that it can have no solutions. And you might have already seen some of those in your 7th grade work. And then the last one is infinitely many. And you might have seen this. Right now, the only ones that we dealt with in this unit, so in this section so far, is one solution. So an equation that simplifies to a blank statement has no solution. An equation that simplifies to a blank statement has no solution. So an equation that simplifies to a false statement, remember, because we were always looking for something that's true. False statement means it has no solutions. For example, this will look something like you do everything and then all of a sudden at the very end you get 4 is equal to 10. Well, that's not true. 4 doesn't equal to 10. So then that would mean that there's no solution. And infinitely many solutions is if you can substitute any number for the variable and get a true statement. Any number. And we'll again go with this. And so you'll see in a little bit. Okay, so here's some examples really quick. So here we subtracted here for this equation. I'm confused here. Oh, here's an equation, x plus 3 equals to x plus 4. Okay. If we subtract 3 from both sides, right, we get x is equal to x plus 1. So here we subtracted 3. We subtract 3 and we subtract 3, then we get this. And so now what I want to do is I want to subtract x from both sides, and we get 0 equals to 1, but it doesn't. 0 does not equal to 1. So this is no solutions. This is no solutions because I can't think of a number that would ever make 0 equal to 1. Give me 1 second. Okay, so continuing, if we had this as an equation, x plus 3, and if I subtracted 3 from both sides here, we would get x is equal to 1. Well, that means that we have one solution, not because the answer is 1, but because look, there's only one number that can make this true. 1 equals 1, right? So that's 1. Let's try this one. I'm going to subtract 3. I'm going to subtract 3. So I get x equals to x, which sounds like a funny statement, right? One is, what number could you put in this equation that would make this true? Well, if I put a 4 here, it'd say 4 equals to 4. Well, if I put a 10 here, it would say 10 equals to 10. So this one is infinitely many solutions because look, this is a true statement. Okay, so continuing on, we're going to do a word problem. It says Kayla sold several $5 bracelets and one $12 necklace. She earned $42. How many bracelets did she sell? It's like, okay. The very first thing that we always want to do is we want to define the variable. So define the variable, and we're going to use x. We could have, used anything, but because we wanted to, we could even use b for bracelets, right? So here we're going to let x be represent the number of bracelets Kayla sold. Okay, done. So the second, write an blank with x. So here we now want to write an expression or an equation. Doesn't matter. In this case, we're going to write an expression, right? Because this is an expression. The difference between an expression and an equation is an expression does not have an equal to sign in it. Okay. So if 5 bracelets were sold, we can write 5x because it would be 5 times x, right? Okay. And then because the 5 is $5 per bracelet. Remember up here, each set bracelet costs $5. And she sold one necklace, which is 12. So if she wanted to figure out how much money she's collecting, it would be $5 times how many bracelets she sold plus the $12 for one necklace. So now they want you to write an equation. And the way we do that is we say the money earned is going to be 42. Remember, that's what they told us. She earned $42. So you're just going to put the 42 on the other side of that equal to sign. So now that we're done, now we have an equation. Now we could just solve for x. That's what we've been practicing this whole time. So we're going to solve for x. And so here again, you're going to ask yourself, you're either going to SADMAP or ask yourself, what's happening to x? So SADMAP says, hey, what is happening first? Do you see any subtraction or addition on the x side? And you're like, yes. So how do we get rid of plus 12? How do you undo plus 12? Well, that's minus 12 to both sides, right? And now you have plus 12 minus 12, that's 0. 42 minus 12, well, that's 30. And now we ask ourselves, okay, we did subtraction and addition. Do you have any division or multiplication? And you're like, yes. Well, how do you get rid of multiplication? Well, we divide both sides by 5. So then our answer becomes 6. So according to this, Kayla sold 6 bracelets. But again, we need to check our answer. Always want to check our answer because then we can make sure that we got everything that we needed. So I'm going to plug in 6 here and see if that's true. 5 times 6 is 30. 30 plus 12 is 42. 42 equals 42. Yay! Okay, so hopefully one of the things that you learned in the biggest takeaways that you're taking here is two things. Number one, when I have an equation, what do I do with it? Okay, the very first thing is know where you want to go. My answer is going to look like x is equal to blank. And so every single step that I take should get me closer to x equals to 6, isolating that variable. The other thing that you should have taken away is the order in which you solve an equation. For me, I use SADMAP. You can use other things as well, but SADMAP, because basically you're undoing all the stuff that's happening to x in reverse order. Okay. And then the last thing I'd say is, with these problems that look really complicated, they're not necessarily new, right? You've known distributive properties since like 4th grade. You know how to collect like terms, but here, if they're on opposite sides, then you're just subtracting or adding so that they are on the same side, right? Okay. And I think that's it. I hope you have a great day. Bye.